In this video, we're going to be discussing linear functions. So the first thing is the slope-intercept form of a line. That's y equals mx plus b. So the m is your slope, and the b is the y-intercept. So the y-intercept would be an ordered pair where x is 0 and y is the b value from that equation. All lines, with the exception of vertical lines, are functions. A linear function can be written in the form f of x equals mx plus b. And notice that the mx plus b is the same. All that's happening is the y is being written as f of x to show that the equation is a function. So you can just replace y with f of x. The average rate of change in a linear function is called a slope. The slope can be found given 2 points with the formula y2 minus y1 over x2 minus x1. So other functions also have rates of change, but they'll be different for different intervals depending on the shape of your graph. A line has a constant average rate of change or a constant change called the slope. So no matter what 2 points you pick on a line, the change will be the same. So this is the formula for the slope. You can also find it geometrically if you have a graph by knowing the relationship rise over run. So it's the change in y's over the change in x's, or how much it increases or decreases on top versus how much it changes in the x direction left to right. So in the first 4, we're asked to find a slope of the line that passes through the given points. And so we just want to use that formula. So if it helps, you may want to label your points. So this is the first point, so I'm going to call them x1, y1. And this is the second point, so I'm going to call those x2, y2. And I know my formula is the difference in y's over the difference in x. And so now I can just plug those numbers in. So that would be y2 is negative 2 minus y1 is 1 over x2 is 6 minus x1 is 3. So negative 2 minus 1 is negative 3 over 6 minus 3 is 3. Negative 3 divided by 3 is negative 1. So the slope of that line is negative 1. So we'll do something similar for number 2. We have x1, y1, x2, y2. We know our formula. So the difference in y's over the difference in x. So 2 minus a negative 5 over 3 minus a negative 1. Remember that the 2 minuses, the minus a negative becomes plus a positive. So that's going to end up just being 7 over 4. So the slope of the line that passes through those 2 points is 7/4. Number 3, we have x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. So 5 minus a negative 3 over 2 minus 2. So that's going to end up being 8 over 0. Remember that you cannot divide by 0. That is undefined. So in this case, you have an undefined slope. An undefined slope, well, let's find the last slope and then we'll talk about all the slopes. So the last one, number 4, we have x1, y1, x2, y2. We're going to use our formula. So we'll get negative 2 minus negative 2 over 0 minus 1. So we end up getting 0 over negative 1, which is 0. So if you divide by 0, like in number 3, that's undefined. But 0 divided by something is 0. So that's okay, and you get 0. Let's talk about what the slope is. The slope is the rate of change. It's how the line changes as you move from left to right. So a slope of -1 means your line will be decreasing over time. So as you go from left to right, it's decreasing. That's an indication of a negative slope. On number 2, we have a slope of 7/4. It's a positive number. So if you read your graph from left to right, it will be increasing. And that's the sign of a positive slope. So since number 2, the slope is positive, the line from left to right will be going up. It will be increasing. An undefined slope goes with a vertical line. So a vertical line has an undefined slope. A slope of 0 goes with a horizontal line. So these are kind of your 4 cases of slopes. You could have a negative slope, meaning the line is decreasing. You can have a positive slope, meaning the line is increasing from left to right. You can have an undefined slope, so it's vertical, straight up and down. Or you can have a 0 slope, so it's horizontal. It's a flat line. Sometimes it's called constant because it doesn't go up or down. Okay, so let's look at what we can do with that. So use the given information to answer the questions. The population of elk in a national forest was measured to be 12,000 in 2003 and was measured again to be 15,000 in 2007. Assume the population grows linearly. Find the average rate of change for this scenario. So the average rate of change, there's a couple of keywords. Linearly is important. When you see that it's growing linearly, you're going to be trying to make some kind of equation that looks like that. Remember that the average rate of change, when it's talking about a linear equation, is your slope. So you're going to be looking for information in order to make a slope happen. Notice that it's talking about a population over time. That is going to be what you use to find your slope. So you have a population and a time. A population and a time. Those are going to be corresponding to your x and your y. Usually, time is your x, and the population will be your y, because your population depends on the year. So depending on how many years have passed, your population will have increased or decreased accordingly. So your x is your independent variable, that's the time, and then your y, your population, depends on the passage of time. So if I want to write those as ordered pairs, I could. So that would be, you can write, now be careful here, you can write the year if you want, but generally when you're talking about time, you're talking about the passage of time, like how many years it's been. So notice the earliest year is 2003. 2003 is going to be the base year. This is when everything starts. So you're going to say that this is 0. So at time period 0, you have a population of 12,000. In 2007, how many years have passed since your base year? You started in 2003, so from 2003 to 2007, 4 years have passed. You can simply just subtract. 2007 minus 2003 is 4. So your second ordered pair is going to be 4, 15,000. So that says after 4 years, you will have 15,000 elk. So there are your two ordered pairs. So you can now use your formula. So this could be x1, y1, x2, y2. So I can use my formula, 15,000 minus 12,000 over 4 minus 0. So that will be 3,000 over 4, which is 750. So the average rate of change is 750 elk per year. Remember that the average rate of change is m. So it's probably going to want me to write an equation, which is exactly what part B tells me to do. Write a linear equation using function notation that represents this scenario. So f of x equals mx plus b is what I want to write. So the m is the average rate of change. So I already know that. F of x is always going to stay f of x in your generic formula, and x is going to stay x. You want to replace the m and the b with numbers. So the m I already know. The b is the y-intercept. The b is your original amount. That is going to correspond to the ordered pair that has an x of 0. So that's going to be that ordered pair. So your b is going to be 12,000. That's your original population at time 0. So there is your linear equation using function notation. So again, your m is your average rate of change, and your b is your y-intercept. And in examples like this, it's your original amount. Part C, what will the elk population be in 2014? So now you're going to use your formula from part B to find the answer here. So think about what our variables are representing. X is associated with the time, because we can see that from the ordered pairs. So X is associated with time, specifically years since our base year. So the number of years since 2003. Okay. Y is associated with population. So Y is associated with the elk population. And remember that Y is the same as f of x. So if it's telling us to find the population, it's wanting us to find Y in 2014. So you want to be able to plug in a number for X. Don't make the mistake of plugging in 2014. Remember that X is the number of years since 2003. So you're going to do 2014 minus 2003, and you see that you get 11. So 11 is what you're going to plug in for X. So plug that in your calculator, and when you do, you should get 20,250. So in 2014, you would guess that there would be 20,250 elk. Okay, the last example. A telephone carrier offers a plan in which they charge a monthly fee of $20 in addition to a charge of 5 cents per minute. Write a linear equation using function notation that represents this scenario. So notice this time they're not giving us two ordered pairs like in the last one. They're giving us a flat monthly fee and a variable fee. So this is another way to look at linear equations. A linear equation or function, the m is the variable rate, or the variable amount, because it's multiplied by x, which is the variable. So whichever one varies according to, in this example, like per minute, the variable charge is going to be the 5 cents per minute. That's what's going to go in for M. So since this charge depends on how many minutes you use your phone. So if you use your phone for 1 minute, you're charged 5 cents. If you use your phone for 2 minutes, you're charged 10 cents, etc. So the amount you're charged varies by the number of minutes you use. B is just by itself. It's not multiplied by a variable. So this is your fixed cost or your fixed amount. So it's the fee that everyone pays. So this is a monthly fee of $20. So it doesn't matter if you never use your phone or if you use your phone every minute of every day. Everyone pays the $20. So that's the fixed amount. So that's going to go in for B. So if you look at it this way, you can write your equation. F of x equals 0.05x plus 20. So the 5 cents is the variable fee and the $20 is the fixed fee. And so there's your linear equation. Notice that the x represents the minutes. Your variable fee here tells you what x represents. Since it's a charge per minute, that means that x represents minutes. And then your f of x or your y is going to represent your total cost. So keeping that in mind, let's look at part B. Last month, a customer was on his phone for a total of 1,250 minutes. How much can he expect to pay? So the 1,250 minutes, that's going to go in for x. So we're going to have f of x equals 0.05 times the number of minutes is 1,250 plus 20. So when I type that in my calculator, I got 62.50 for 0.05 times 1,250. And then when I add that to 20, I will get $82.50.